So when we're talking about parallel lines, we're talking about lines that have the same slope. Having the same slope would mean that they are moving at the same rate and therefore would never get any closer or any further apart from one another. If you're given a graph and asked to determine if they're parallel, perhaps you can tell from the graph itself, perhaps you cannot. But if you calculate the slope, you should be able to tell from their slopes. So if I'm doing slope of this line here, from 8 down to 0 is a drop of -8 and then over 2. So this slope would be -8 over 2 or -4. On the second line, I have a drop of 5 to -4. That's down 9 and over 2. So this one's -9 over 2, which is not -4. It's -4.5. So although these look very parallel, possibly, these are not parallel because they do not have the same slope. So same thing on this one. If I was looking to determine if these are parallel, then I would do rise over run here to get the slope. So that's going to be 2 over 1, 2, 3, 4, 6. So 2 over 6 would be 1/3. And then same thing here. I would do a rise of 2 and a run of 6. So these are identical. And since they do have the same slope, these are parallel lines. Perpendicular is a little trickier. So perpendicular means that the product of the slopes has to be -1. This is what we would call a negative reciprocal. So reciprocal is something that you should hopefully be familiar with by now, meaning that the fraction itself has been flipped. So we want to look for one positive and one negative slope, because we need one to be moving up and one to be moving down in order for them to even have a chance of being perpendicular. So that would mean they cross at 90 degrees. And then we want the fraction itself to be a reciprocal, so we want the slopes to be reciprocals. That just means they need to be flipped over, right? So we're looking for something like 2/3 and 3/2, and then either of those needs to be negative. So like -2/3, +3/2, or vice versa. So if I want to determine if these two lines are perpendicular, I would do like I did with parallel, and I would find the slope. So this is going to be -3 over 3, which is a slope of -1. And then for the second line, we have a rise of 5 and a run of 7. So that's 5 over 7. Those are not negative reciprocals. One's negative and one's positive. That's good. But 1 and 5/7 are not reciprocals. So this is not perpendicular. These are just regular intersecting lines. If we were given the equations, we could just look at what the slope is on the equations. Same thing here. So if we're looking to determine if they're perpendicular, this one has a rise of 3 and a run of 6. So that one is 1/2, which means the other one needs to be -2 over 1 because it needs to be the reciprocal. Let's see if it is. So this would be down 1, 2, 3, 4, 5, 6, 7, 8, and then over 4. So -8 over 4 is -2 over 1, or just -2. And so these are negative reciprocals, and so these lines are perpendicular. Okay. And then if we're doing horizontal and vertical lines, these are the ones that tend to be a little harder for students to write the equations on. The key to this is whichever axis it passes through is the variable you use. So if I'm looking at x equals 4, that's right over here. And so this line would be a vertical line where x is 4. So it has to cross through the x-axis. If I then want to have a line that is perpendicular to x equals 4, then that means I need a line that's running horizontally instead of vertically. It has to go through 3, -2, so 3, -2 is right here. And that just kind of tells me where the line has to be. It has to run like this. That's not very perpendicular, but let's fix it. Okay, so like this, and then it has to pass through that point. So that line would have to be a y line because it crosses the y-axis, and it has to go through this point, so it has to be that y value. So y equals -2 would be the equation of the line that passes through that point. Same thing here. If we're going to have a line at y equals -3, that's going to be on the y-axis at -3. So that's this horizontal line here. If we want it to be perpendicular to that line, I don't know why the x equals 4 is here. It's because I'm copying and pasting, not doing a great job. Okay, but we want it to be perpendicular to y equals -3 and go through the point 2, -4, which is right here. So if I'm going to be perpendicular to that, then I need to run up and down, and so that line would be an x, because it goes through the x-axis. So that would be x equals 2, because it has to go through this point, so I just take the x value there. If I want to be parallel or perpendicular to the axis, then I want to say, okay, I got to go through 4, 1, that's over here. And I want to be parallel to the y-axis. Well, y runs vertically, so this line needs to run vertically. And if you're not given a graph on these, I would definitely graph some graph paper and I would graph these. It makes it so much easier. So I got to be a vertical line. That means I'm going to cross the x-axis where it's 4. So this is the line x equals 4. Same thing here. If I want to go through the point 2, -4, which is right here, and I want to be parallel to x, now I'm talking about a horizontal line, and a horizontal line passes through the y-axis. And so this would be y equals -4, because that's the y value from the ordered pair. Okay, now if you're asked to give the equation and it needs to be parallel, then that means they have to have the same slope. And so this one needs to be parallel. The slope of this line is 7. And then it has to go through this point. I would do point slope form, and then you could leave it point slope form, or you could convert it to slope intercept. So we could say y plus 4 equals 7 times x minus 1. Remember, it's minus in the point slope formula, but -4 is going to change it to plus. If you want to turn this into slope-intercept form, then you just have to distribute and move that 4. So that would be 7x minus 7, and then if I subtract 4, I would have 7x minus 11. And so that is the parallel line with the same slope that goes through that point 1, -4. There are infinite lines that are parallel, but there's only one that would go through this point. So that the point is important here. But you do want to use this same slope of 7. That has to match if they're parallel. On this one, if we want to be perpendicular, this is the same equation. So instead of saying my slope has to be 7, it needs to be its negative reciprocal. So I need it to be negative since this one's positive. And then 7 is technically over 1, so I'm going to flip it to 1 over 7. And then using this point, I would say y plus 2 equals -1/7 x minus 21. Then if I want to get it to slope-intercept form, which is not necessarily required, but most of you guys prefer slope-intercept, then negative times a negative would be a positive, and then 1/7 of 21 is 3. And then minus 2, and so this equation would be y equals -1/7 x plus 1. And that one would be perpendicular. It has that negative reciprocal slope. And then I used the point that was given. Point slope form is definitely the way to go here. If they don't give you the slope, so if it's something like this where it's in standard form and they didn't even give you the slope, you will have to find slope first. To find slope from standard form, solve for y by itself. So we subtract 3x. That leaves us with -4y equals -3x plus 12. divide everything by negative 4, negative 3x divided by negative 4 is going to be positive 3/4 x, and 12 divided by negative 4 is going to be negative 3. Now I know that the slope is 3/4. If it needs to be parallel, the new slope has to be 3/4. So I would do y and then plus 2 from the ordered pair, and then 3/4 times x minus 8. If I needed to solve it from there to slope-intercept, of course I could. That goes back to unit 5 that we just tested. So that would be minus 6, and then if we subtract 2, we would get y equals 3/4 x minus 8. But you do have to find that slope yourself from standard form. So you do have to do a little bit of extra work if they don't give you slope-intercept or point-slope form. So like on this last example here, it's not slope-intercept form, but it's in point-slope form, and so they still gave you the slope. The slope's 2/3. If you need to be perpendicular to that, you're going to flip it, call it 3/2. It's positive, so now we're negative. If it were negative, we would now be positive. It's just you got to have one of each. And then we would have, from this ordered pair, 6, 3, we would have y minus 3 equals negative 3/2, and then x minus 6. So y minus 3 would be negative 3/2 x, and then this would be plus 9, and then if you add 3 to that, your new equation would be y equals negative 3/2 x plus 12, and that would be perpendicular to the original equation.